All right, boys and girls, welcome back to the drive-thru. Sponsored as always by the deli. Hungry? Stop by the deli. Make yourself a turkey and pepper jack sandwich on a honey bun with spicy mustard, some chips, and some peanut butter filled pretzels. It was a good lunch today. Very solid. All right, this is 8.3, Methods of Proving Triangles Similar. If you remember, we took like 3 different sections to learn all the ways to prove triangles congruent, and since you guys are really good at that, we kind of wrecked this all out in one quick little section. So it can kind of be difficult, but hopefully you guys will follow along pretty easily, okay? We already learned that similar figures have corresponding sides. So if this side was, well, let me do this. If we had A, L, I, E, E, N. Okay? Well, if we knew that if we had to use the long way to prove these triangles similar, we'd have to prove that angle A was congruent to angle N, that angle L was congruent to angle E, that for a lack of, I'm just shortcutting, angle I's were congruent to each other. Then you'd also have to show that the ratio between AL and EN was the same thing as the ratio between AI and NI, and that would be the same thing as the ratio between EI and LI. And that would take a long time to prove all that, and it would be annoying. So luckily for you, we have shortcuts. There are 3 shortcuts. The first one is the one that you will use the most, and that is the AA method, okay? That just simply says if 2 angles from my triangle are congruent to 2 corresponding angles from your triangle, then those triangles must be similar. Why is it only 2? Couldn't the third angles be different and therefore it wouldn't be a similar triangle? What do you think, class? No. What theorem tells us that the third angles cannot be different? The no choice theorem. Okay, so that's why it's AA and not AAA. A? A. Okay. Method 2 is called SSS similarity. So it's not to be confused with side, side, side. So you can call this SSS with a tilde, or maybe in this class, starting this year only, we should just call it SSSS. We could also call it the snake theorem, and we will include that in another set of parentheses. My friend Snake will like that. Well, it's my friend's alter ego. His name's Chris, but when he's in Hilton Head, his name's Snake. Okay, it's a long story. Okay, so what this says is that if the ratios between the side lengths are all the same, okay, so here we have ABC. Sorry, I got no creative thought today. So here's how you have to prove the snake theorem. You have to prove that the fraction between AB and XY gives you the same fraction as the fraction between AC and XZ, and that's the same fraction as BC over YZ. So you can kind of imagine that we're going to need numbers to do that, so it won't be your typical 2-column proof. Okay? The third way is the side angle side similarity shortcut, or the sassy snake theorem. Okay? And what this one says that if you've got, oh man, that is not a triangle, but we're going to move on. If you've got Ron and Eli Okay? And you know that angle R is congruent to angle E. And have a great day. We'll see you guys tomorrow. And you know that RO, thank you, Shane. I'll see you at your school, over EL is equal to RN over EI. Then you know that those triangles are similar by SAS similarity. So notice you would have like, maybe we'll mark it like this to indicate similar or proportional. There you can see kind of the side angle side. So hey, we're just going to finish this up by doing two examples. One is like your standard two-column proof. That's this one. So here's example one. ABCD is a parallelogram. Okay? And we want to prove that triangle BFE. Okay. So I think this screams AA because of parallelogram. So the first thing I'm going to do is just do the easy thing. Angle BFE is congruent to angle CFD. And that's by vertical angles. So I know this is congruent to this. Okay, now I can say that DC is parallel to AB. And that would be if parallelogram, then opposite sides parallel. So now I can say that those angles are congruent, that angle C is congruent to angle FBE by alternate interior angles. If lines are parallel. And now I've got triangle BFE is congruent to triangle CFD by AA postulate. Okay? All right, our final example. Three sides of one triangle are 8, 14, and 12. And another triangle is 18, 21, and 12. Let's see, so the biggest one's got to be here. The second biggest one's got to be here. And then the smallest one's got to be here. Prove that the triangles are similar. So, just do this. 21 over 14 equals 3. 21 over 14. 21 over 14 is equal to, divided by 7. 3 to 2, thank you. 18 over 12 is equal to 3 over 2. And 12 over 8 is equal to 3 over 2 by these triangles are similar. Boom!